Hey everyone, welcome back to another video of our multi-threading in Java series. In this video, we will be solving the problem you see on the screen, which is ping-pong printer problem. So let's dive into that. In this problem, you have to create two threads. Let us name it as T1 and T2. Using one thread, you have to print ping, and using another thread, you have to print pong. Now, one of the restriction here is this ping and pong should be printed alternatively, and ping should only be printed using T1 and pong should only be printed using T2. So our expected output will be ping, then pong, then ping, then pong, and you'll have to make sure this is printed by thread T1, then T2, then T1, then T2. In our last video, I gave you this particular hint to solve this problem, right? Now let's dive into the actual solution of this problem. Let's start first by building some intuition. So basically what we want here, we have two threads T1 and T2. Using T1, we want to print ping, and using T2, we want to print pong. We also know at a single point of time, either ping should be printed or pong should be printed. So our first step will be to give control to either T1 or T2. At a single point of time, either T1 will be in control of the whole program or T2 will be the control. First, let's go ahead and block this particular thread, right? And give control to T1. So our step 1 will be to block this thread T2, and step 2 will be we'll ask T1 to take control of the complete program. Okay. Now what will be our step 3? So after taking control, T1 will go ahead and try to print ping. Third step will be to print ping, right? Now what will be our fourth step? This is the most important step. At this step, what does T1 wants? T1 has already printed ping, right? So now T1 should go ahead and block itself, and after blocking, it should go ahead and give the control to T2 and give control to T2. Why this? Once T1 blocks itself, it won't be able to print ping again, and when it gives control to T2, T2 will be completely free to take control of this whole program and print pong, right? So in step 5, T2 will be taking the control of the program. In our step 6, you must already have guessed, T2 will go ahead and print pong. And in our 7th step, after printing pong, what will happen? After printing pong, now T2 wants to block itself, right? Because it is chance for T1 to print ping. So in this last step, T2 will go ahead and block itself and give the control back to T1. So step 7 is block itself and give control to T1. So control is again back to T1. After this 7th step, since control is again back to T1 and T2 is in blocked state, again this series of steps will be executed. Okay. So after one cycle, what will happen? After one cycle, ping will be printed by T1, pong will be printed by T2, right? Then again control will be with T1 and T2 will be in wait state. Got it? So what we have to do? You have to repeat all these steps again and again in a loop. So all these 7 steps, whatever we have seen for T1 and T2, these steps will be inside a loop. Okay, when we will write code, all these 7 steps will be inside a loop. Now let's go ahead and convert this intuition to our actual program. So here I will be writing the code for thread 1 and here I will be writing the code for thread 2. So what is the first step? So we all know that whatever we have to write it inside the loop. Let's go ahead and write an empty loop here. We'll fill the body in some time, and one empty loop for thread 2 as well. Okay. Now what is the next step? Next step is so T2 should be in block state and T1 should take control. Now if you remember the hint which I gave you in our last video, which was use one semaphore named as ping semaphore with 1 permits and another semaphore named pong semaphore with 0 permits. Let's go ahead and do that. So let's create a semaphore here. Semaphore ping semaphores equals to new semaphore, and this is very important. We are giving it one permit. Why we are giving it one permit? You'll just know in few seconds. Let's go ahead and declare another semaphore named Pong semaphore. So we have created another semaphore named Pong semaphore, but it has permit 0. Now, what is the step? The first step is Pong should be in wait state. Now, how can this particular thread be in wait state? We have already seen in our last video, if we have 0 permits for a semaphore and we still go ahead and try to acquire the permit, our thread will be in blocked state, right? So let's go ahead and write Pong semaphore dot acquire. So what will happen at this time? Thread 2 will try and acquire this semaphore, acquire the permit that this semaphore has, but as we can see, it has 0 permits. So automatically CPU will go ahead and put this particular thread in block state, right, or wait state. So this is blocked. Our first step is done. What is our second step? Second step is for T1 to take control of this complete program. Along with Pong semaphore, we also have ping semaphore here. What if I write ping semaphore dot acquire? If we write this, will this work? Yes, this will work. Why? Because how many permits we have here? We have one permit here. Ping semaphore dot acquire. Thread 1 will go ahead, take this permit, and now the number of permits after this step changes to 0. But it is allowed to acquire a single permit because this semaphore has 1 permit. So this will be executed correctly. After this, what is the next step? Next step is to print ping. Let's go ahead and print that. We have printed ping here. Now what is the fourth and the most important step? It is block itself and give control to T2. So let's first go ahead and give control to T2, and then we will see how T1 will block itself. So for giving control to T2, we see here T2 is blocked because Pong semaphore has no permits. So let's go ahead and release some of the permits for Pong semaphore. After we release some of the permits from the Pong semaphore dot acquire, this will be a valid statement, and whatever permits we have released, those permits will then be acquired by Pong semaphore. If I go ahead and write here Pong semaphore dot release, Pong semaphore dot release, at this point of time, the permit of Pong semaphore increases from 0 to 1. Now as soon as permit increases from 0 to 1, CPU will say, hey thread 2, Pong semaphore now has 1 permit. So you are allowed to acquire a permit using the statement which you were using earlier, right? So now thread 2 will be in control. Thread 2 will acquire 1 permit from the Pong semaphore, and it will go ahead and execute whatever instruction we are about to write here. But first, let's go ahead and complete this step. So we have given the control to T2, but how can T1 block itself? So if you see clearly, after executing this statement, T1 will go ahead, since it is in a while loop, and try to execute this statement again. Ping semaphore dot acquire. But after executing this loop for the first time, the count of permits of ping semaphore has already decreased from 1 to 0. So second time when it goes ahead and write ping semaphore dot acquire, at second time the CPU will go ahead and block this thread. Why? Because at this particular point of time, at second iteration, the permits count has already decreased to 0. So it cannot acquire, and therefore CPU will go ahead and block this thread, and this thread will be in waiting state. Okay, so thread 1 has blocked itself only because it has already acquired 1 permit in its first iteration. Okay, so this step is complete. What is step 5? Step 5 is taking control. So Pong semaphore dot acquire, this is executed correctly. So thread 2 has taken control from here. What is step 6? Step 6 is to print Pong. So let's go ahead and print Pong. Right, system.out.println, Pong is printed. What is the next step? 7th step. Block itself and give control to T1. How will we give control to T1? T1 is blocked on ping semaphore because there are no permits available. So let's go ahead and release a permit so that thread 1 becomes in control and it is released from waiting to running state. So when we write ping semaphore.release, the permit count of ping semaphore increases from 0 to 1, and after it increases from 0 to 1, CPU says, hey thread 1, you are trying to acquire permit from ping semaphore, right? Now the permit is available. You can go ahead, acquire this permit and try to execute your further code. Okay. Now T2 has given control to T1, but how will T2 block itself? If you see here clearly, same as thread 1 did, after executing this statement, T2 will again go ahead and try to write pong semaphore.acquire. But it has already acquired a permit in the previous iteration, right? So the permit count has already changed from 1 to 0. If it tries to acquire for the second time, CPU will go ahead and again block this particular thread, right? So this is how T2 blocks itself. And now, since T1 is unblocked, T1 will go ahead and run. So after first iteration, ping was printed by T1, pong was printed by T2. Then again, P1 has control, P1 will go ahead and again print ping, and similarly T2 will again print pong, right? So this is what our pseudocode looks like. Let's go ahead and code it in our IDE. Let's start by creating two semaphores, ping semaphore and pong semaphore. Semaphore, ping semaphore equals to new semaphore, and let's give it a permit of 1. Let's go ahead and create pong semaphore, and pong semaphore will have permit 0. Now let's go ahead and create two threads. Thread 1, right? In thread 1, what we'll write? For infinite amount of time, go ahead. Our first step is to take control. So it will take control using ping semaphore.acquire. Let's put this in try catch. After this first step, what we will do? We'll go ahead and print ping. Also, let's print the thread name here. So right? Now third step here will be to block itself and give control to thread 2, which will work on pong semaphore. So what we'll do here, pong semaphore.release. Okay, for thread 2, let's copy this code and create thread 2 here. Thread 2, what it will do, it will go ahead and acquire pong semaphore first. Post that, it will print pong, and after that it will release a permit on ping semaphore. Post this, let's go ahead and start both the threads. Thread 2.start. I think this looks well. Let's go ahead and run this. Oh, so it is printing infinite times, but if you see, ping is printed by thread 0, pong is printed by thread 1. Ping, pong, ping, pong, ping, pong, and the corresponding thread name is also printed on side of it. Now instead of printing it infinitely, let's go ahead and print it for 10 times. Let's create a variable named max limit, whose limit is 5. I'll tell you why it is 5. I less than max limit, and copy the same code here also, right? So 5 times ping will be printed and 5 times pong will be printed. Okay, so total it will be 10 times. Now let's go ahead and run this. Right, so you can see ping by thread 0, pong by thread 1, ping pong, ping pong, ping pong, and it is printed for 10 times. Now the logic that we see here, this is such an interesting and very important logic that is required whenever you have to do alternation between threads. If I go ahead and show you another problem, which I have it in my list, we have coded this ping pong printer problem, and the next problem is Foo-Bar alternation. So no change is required. Instead of printing ping, just print foo, and instead of printing pong, just print bar, and our problem will be done. So let's go ahead and do that. If I go here, instead of ping, I print foo, and instead of pong, I print bar, and try to run this, right? Foo-bar, foo-bar, foo-bar alternation. So you can see how elegant our code has become, right? So simple, so elegant logic using semaphores for alternation of threads. Using one technique, we have solved both the problems, ping-pong printer problem and Foo-Bar printer problem. I hope you find this video insightful. Until the next video, stay safe, stay healthy. Bye-bye.